Alright guys, so we have been practicing how we can find circumference, and now we're going to actually look and see what happens with your formula chart. So we've been looking at, the first day we looked at circumference, we used our paper plates and we cut them out and we measured that they were about 3 of your diameters and that little extra that would fit for that circumference when we measured it out. Then, so we used an estimation of 3. Then in the previous lesson, we said, well, pi is approximately 3.14, so we did math with 3.14. Well, now we're going to actually say, okay, well, this represents the formula chart that you're going to be using for your class tests and your end-of-the-year state tests. So the formula tells us how to write your equation. So the difference between a formula and an equation, a formula is just what's standard that you're always going to use, and the equation is when we actually substitute the numbers. So if you guys think about it, we said the RDC times 2 times 3, and then we change it to the next day when we practice the RDC times 2 times 3.14, and that was really what pi was. So if that visual helps you, you can use that. And then if we're going backwards, we're dividing by 3.14, if that's what the directions give me from circumference to diameter, or divide by pi, that irrational number. And then from diameter to radius, we're always going to divide by 2. Okay? So these formulas make sense. And if you think about it, pi is approximately 3. So 2 times 3 is 6. And when we used those paper plates and we measured it out, it was about 6 of your radius to fit inside the circumference. Well, here again, if pi is approximately 3, or 3.14, 3 times diameter, well, again, that's why that paper plate activity made sense. It was about 3 diameters with that little extra. So what we're going to look at today is we're going to always identify your information first. So the radius is from the center to the edge, so that's my radius. My diameter is from the edge or the outside through the center to the other outside. So you have to identify the numbers that are given so you use the correct formula. That's how some of these problems trick you, because if you use this number, 6.2, with this formula, that could be a trick answer, because this is the formula we use for radius and this is the diameter. Okay? Same thing with this. If you did your math right, but you used this formula, that's where you're going to fall for a trick answer, because that's not the diameter, that's the radius. So what you always want to do before you start with your formula and then substitute with your equation is you want to identify what's given to you. So if this is the diameter, the equation I'm going to use is C equals pi times my diameter. Now today we're going to go ahead and keep pi. So we're not going to write 3, we're not going to write 3.14, we're going to use that irrational symbol pi. Then the diameter, that's the number I'm substituting, so this is making my equation. So formula is what's on the chart, the equation is based on the numbers you're using, so the diameter is 6 2/10 millimeters. So now, using my Desmos calculator, I can figure out, for the calculator that I'm using in class. Easier to see this one though, so I'm just going to show you with that. If I can flip my phone to get the pi symbol. Alright, so we're going to say pi, again that's approximation of that 3.14 times 6 2/10, and they give you this long number, 19.4778, and so on. So we're going to round it to the nearest thousandths. So tenths, hundredths, thousandths. So you only have to look at this number. So 4 or less, we're going to let it rest. 5 or more, we're going to add 1 more. Okay. Now, depending on the calculator you're using, it might actually stop. But we can see that this number is going to go on and on forever. And the reason why this is going to go on forever is that this irrational number, that 3.14, continues on forever. So this is an approximation. Now, if your calculator, depending on what calculator you're using for class, it might have given you 19.4779. So if that's where it stops, it's because of how they estimated it. So you can see right here, I went 4778 but just depends on what numbers you're looking at. So it's just kind of depending on what calculator you're at. So we'll make sure we can practice with that. All right. Now the next one, this is my radius. So am I going to use the formula 2 pi r or pi d? Well, if I know the radius, then I'm going to use 2 pi r. But here again, we can use estimation even to rule out any answer choices. 2 times 3 is 6, or you can even use this mnemonic device, radius times diameter. So see this, 2 times r is your diameter right there, and that's why you're multiplying by pi again. So it just depends on what you're looking for, okay? But using the processing, we know that the circumference is equal to 2 times pi, we're going to leave pi, and the radius is 2 5/10 centimeters. So pi is the best number we can use, the closest we can do for circumference, but remember you can't ever actually find the actual circumference because it's not a straight line to measure it, so that's the closest we can get. So 3 is an approximation, 3.14 is a closer approximation, but pi is going to be the best one because it gives you the most, not accurate, but the closest circumference you can. So I'm going to say 2 times pi times 2.5. And that's giving me 15.70796, and it goes on and on forever. But if we're going to round to the nearest thousandth, so that's tenths, hundredths, thousandths, we need to look at the number in the 10,000ths. Okay? So if I'm estimating this based on where my calculator stopped, 4 or less, we let that rest. 5 or more, we add 1 more. So this is going to be 15.708 thousandths centimeters. Don't forget your units. Okay. Again, if you used your estimation from the first day we did this, your radius doubled as your diameter, so that's 5. There's about 3 of your diameters to make your circumference, so 3 times 5 is 15, but there's that little extra because that pi is not exactly 3. Okay, something to think about. So on this next one, we're not going to solve these. We're just going to say which formula would you use. Okay, so we need to identify radius or diameter. So I'm going to use my colors that I was using for radius and diameter. So from the center to the edge, that's your radius. So if you're using that's your radius given, that's the formula you would use to solve. This chord, this line, is going from the edge to edge through the center, and that's your diameter. So we're going to use this formula. So if you want to solve these, you can, but right now we're just focusing on what it looks like from here. From the center to the edge is your radius, so this is the formula you would use. Okay? Just again, remember, if you have a circle, you can kind of see it this way. If I have a circle like this, another circle like this, from the center, you can put one R there, and another r there, so that's your radius, so that's why it's 2 radius times pi, and then you can make the letter d for your diameter. Okay, so that's why it's also 2 radius for every 1 diameter. Just something to think about. All right, let's look at these last 2 problems, and then you'll get some practice on your own. So it says, calculate the circumference of a circle with a diameter of 8 5/10. So am I going to use pi, c equals pi d, or c equals 2 pi r? Well, if it's the diameter, then I need to use the formula c equals pi d. So when you're showing your work on your paper, you always want to start with your formula. Then you start with next is your equation. So we're going to keep pi. The diameter is 8 5/10 meters. And then we're going to get our answer. So it's always going to be formula, equation, then your answer. That's how you show your work. Okay, I'm going to set this other one up and then we'll solve them. What is the circumference of a circle with a radius of 26 feet? Well, again, which formula am I going to use if they're giving me the radius? So the radius, I'm going to use this one. So my formula is c equals 2 pi r. Then I go to equation. 2 stays the same. The pi stays the same. Those are my constants right there. And my radius is 26. Okay, then we're going to solve. Make c equals. And then we're going to go ahead and use our units too. All right, so now that that's all set up, So pi times 8 5/10 is equal to 26.703. So the 3 is in the thousands place, so look at that 5, 4 or less, let it rest. 5 or more, add 1 more. So that's going to be 704 thousandths meters. Again, if your calculator goes a little bit further and stops, you can use that number. But when we see if it's like multiple choice, we can see that that's the closest to it. So again, just read the directions, because sometimes if they tell you to round to the nearest tenth, hundred, thousandths, we can get that for you. All right, now the next one, 2 times pi times the radius is 26. So we got 163 and 362. Well, that's the thousandths. So look at the next number, 4 or less, let it rest. 5 or more, add 1 more. So that's going to be 163 and 363 thousandths. And that was in feet. So again, remember, circumference is just the approximate, keyword is the approximate estimation of your perimeter. Now again, before you even do the math, you could use substitution. This number is about 3, 8.5 is about 9, 3 times 9 is 27, and that number is pretty close to 27. This number is already 2, pi is about 3, 2 times 3 is 6, and if you did 26 times 3, well 6 times 3 is 18, carry the 1, 3 times 2 is 6 plus 1, let's see, let me make sure that I did that right. Just some things to think about. Make sure I typed in everything right. So if you said 2 times 3 is 6, and then 6 times 26 is 156, well, of course, that's going to be a little bit over because you have that little extra. So that's something that you could rule out, because sometimes the numbers are close, but the decimal's in the wrong spot. So just something to think about. All right, guys, so this is what we're going to be using. So just read through the following problems carefully. If they ask you to use pi, that's what we're going to use in our calculator. If they ask you to use 3.14, then that's what you're going to substitute here. Okay, but this is what these formulas mean when you look at them. So this is why we kind of looked at breaking this lesson up before just starting day one with these, because you would say, well, why are those formulas like that? What's the point? Where did these come from? So breaking it up from that paper plate activity, you can see that, okay? All right, as always, let us know if you have any questions on your assignment, and good luck.